Welcome all of you to this first session of artificial intelligence and its practical application. Although artificial intelligence is an emerging subject and a lot of things are still under evolution, but we have done a little bit of brainstorming and tried to identify speakers who are practically using the artificial intelligence in their day-to-day life in various fields. So we requested them that let us focus on certain practical aspects because there's a lot of theoretical stuff to artificial intelligence.
Breached a payroll.
So we are very fortunate to have three eminent speakers with us. And we will, without wasting much time, I'll move on to the first speaker, Dr. Vipul Nayak. He is an IITian, and I'll request Dr. Ramesh Babu, is the moderator of the session, to please introduce him and proceed with the talk.
Welcome, Vipul. Vipul Nair is born and brought up in Haldwani, Uttarakhand. He is an MBA from FMS Delhi and BTech from IIT. He's an avid reader and quite passionate about AI and gaming. He's also a big fan of Agatha Christie, Jose Mourinho, Rafael Nadal, and all whatnot. So quite a interesting profile and a very knowledgeable person. And we are absolutely eager to listen to you and then learn from what you're going to offer. Over to you, Vipul.
Thank you. Thank you. So I'll be sharing my screen. Just let me know if my screen is visible. Can you see my screen?
Make it full screen and move a couple of slides. Let us see whether the slides are moving also.
It's working, right?
Yeah.
Perfect. So this is one of the questions that I ask in all of my presentations, all of my sessions. So just let me minimize this. So what is your view on this line? AI will take your job. What do you feel about this? Do you feel this is true? This is valid for you? This is valid for someone else who you know?
Do you want us to be talking in between and be interactive?
Just on a few slides, I would want some interaction, some sort of interaction. What is your feeling? You can also put your answer in comments if possible.
Yeah. See, I personally feel that the kind of jobs will shift from doing the real tech jobs to how to use AI. See, we've always been shifting our roles. So we'll be using the AI rather than, replacing the AI. So we have to learn how to use AI. That will be the shift rather than losing jobs, I think.
Perfect. So when I ask this question to people who attend my sessions, most of the times I get an answer as yes, maybe not in this case. So what I tell them is exactly what you said, sir. Yes. So instead of saying that AI will take your job, you should rather make AI as your ally and tell everyone that AI is going to take my job to the next level, because this is exactly what it offers to us if we make it as our ally. And the purpose of this workshop is to help you make Gen AI tools like ChatGPT your ally, your perfect ally, which will help you in your daily lives, day-to-day work. So now, the first question that I'm going to ask you, the second question that I'm going to ask you is whether you feel that ChatGPT is useless, because this is another thing that I keep listening from people all over the world, that ChatGPT bekar hai, ChatGPT is useless, not for me. What do you feel about this? What do you guys feel about this? Do you feel that ChatGPT is useless? Useless, okay.
ChatGPT is, I think what Vikesh said is perfect, used less. So if you know how to use it, then it can do wonders. But if
Excellent.
you don't know how to use it, and then you put the wrong questions, obviously it will give you a wrong answer.
Perfect. So basically you answered my next slide. ChatGPT is useless only if not prompted properly. It is Gen AI tools like ChatGPT works on the logic of garbage in and garbage out. Garbage in, matlab, if you give a garbage input, you'll get a garbage output. As simple as that. So this is what I'm going to teach you guys in the next few slides, that how to prompt properly to ChatGPT to get a perfect output as per your requirement. So before that, I just want to take you through some basics of Gen AI. So ChatGPT is basically generative. GPT is generative pre-trained transformer. Chat is because it is conversational in nature. Pre-trained because it is trained on a huge sets of data, because of which it is able to answer our questions very accurately. Not 100% accuracy, but yes, to a great extent of accuracy, because it is trained on that set of data. Some fundamentals, NLP, I'm sure that you must have heard about this, natural language processing, because these tools interact with you as if you are interacting with a human. Prompt engineering, this is something, I keep telling people that prompt engineering is actually the skill of the future. What it means is that whatever instruction that you give, which is basically a prompt to a GPT model, to a model AI, Gen AI model like ChatGPT, this skill helps you extract the best output as per your requirement, which is the most effective output. Token is the currency of ChatGPT or other Gen AI models. It is basically so ChatGPT and other models like Claude, for example, does not understand words or characters. It understands tokens. So for example, whatever word that it generates as an output, it basically understands as token. In general, one word is equal to 0.7 one token is equal to zero point 0.7 words, roughly around that. Multimodal. So you must have seen that today you are able to give a file as an input to ChatGPT or an audio as an input to ChatGPT, not just text. So this is what exactly multimodal is, because you are able to give an input to these Gen AI tools in the form of text, in the form of files, in the form of audio, video, image, etc. Hallucination. So this hallucination is a very popular word. Why I'm saying this? Because this was so popular that dictionary.com called it as the word of the year in 2023. What hallucination means in the terms of in the realm of Gen AI? So sometimes you must have observed, I don't know if you have observed this or not, whenever you ask a question which requires some fact, Gen A sometimes gives you an answer stating that as a fact, but it is not accurate. So this is what exactly hallucination is. Just like humans sometimes lie, right? If for example, if you ask someone a question and a human a question and usko answer nahi pata hai, and if he gives a response which is a made up response to some extent, just like that, Gen AI also does that sometimes. That's why you should always fact check the answers that Gen AI gives you, because it hallucinates sometimes. If I talk about today,
AI के बारे में है
the latest Gen AI models hallucinate very less. It is less than 1% today in some models, but still fact checking has to be done always and always. Now, talking about good prompt versus a bad prompt, let me take you through an example. So this is what ChatGPT looks like. You can see 4.5 ChatGPT 4.5 model. Uh, right now it is not available for all users because I am using a pro account, ChatGPT Pro account. So that's why it is available for us. It was live 2 days ago, but ChatGPT Pro users and maybe free users might also get it in future. So let's take a use case. Let's take a use case where one of the doctors named Dr. Sharma is invited uh, for a as a keynote speaker for a medical conference. Now, Dr. Sharma has to send a response via email, acceptance response via email to the invitees. So he wants a draft from ChatGPT. Okay. So let me write it as, can you help me with an email acceptance uh, email which will go as an acceptance of an invitation for a medical conference where I have been invited to on 31st March 2025. Okay. So this is a prompt that I have given it asking for an email response. Okay. So if you see the output, yes, it was able to generate an output for me, an email with a subject line as well. But a lot of things are missing here. Why? Because perhaps my context was not clear. There were some details missing on my part. So because the input was not extensive, that's why the output was also not extensive. Some of the details were not captured in the output. That's why it's always better to put all the details, all the possible details in your input prompt to get a perfect output. And now I'll show you how a good prompt looks like. Let me show you a framework that I follow. Okay. So this framework that I keep using in my prompts is called as RCC framework. R stands for role. You give a role to ChatGPT. For example, here I've given an example of a professional email writer, for example. Context, whatever context that is available to you, you give it to ChatGPT in your prompt. Constraints or instructions or rules, you can set guardrails around the response that you want from the Gen AI tool like ChatGPT to get an output as close as to your requirement. And lastly, emotional stimuli, E, which is emotional stimuli, it could also be example. So I'll take you through it. For example, this is another version of this prompt. Now, if you see, I have given it a role of Ramesh. He's an expert in writing professional emails for any context provided to him. His writing style I have defined here. Then context. Now, Dr. Sharma is a client of Ramesh, who has been invited by Indian Medical Association as a keynote speaker. Then I have defined rules, which while crafting an output email, these rules have to be followed. And lastly, one-liner emotional stimuli. So what emotional stimuli does it makes a response much better. So this is not me saying, this was a research done in 2023 by some researchers, that when you add some sort of emotional stimuli, like for example, this is very important for my career, or I will lose my job if you don't give me the best output, something like this, an emotional stimuli, then the output becomes 10 to 20% better. So I usually add an emotional stimuli at the end of my prompt. So let's see how ChatGPT will give me an output. Okay. So this is my first half of the prompt where I'm giving it a role. Okay. So it has given me high five now. Then I'll ask it for an email. Now, the reason why it is giving me two options is because I've asked it for two options. Also, now if you see, it has started following the instructions or rules that I had mentioned in my prompt. Some of the words, important keywords are highlighted in bold. There is a structure. It has already captured my name, my client's name, which is Dr. Sharma. It has also captured the location where he lives in, date, and where the conference is. Plus, it is also giving me a subject line. So this is a basic example, I would say. But normally, the prompts that we write as a team, as a marketing team at HDFC Bank, range from 2000 words to 3000 words. They are huge. So the reason why I'm highlighting this is because the more context you add in your input, the better output you will get. As simple as that. Okay. So moving on. So there are some tips which will help you to further improve your outputs. Let me take you through these tips. The first is chain prompting. What exactly is chain prompting? Now, for example, in this case, in this window, I have got two email responses as an output. Now, let's say if I want uh, to edit some part of this email, I have some feedback on email template one. So I can put that as a prompt in the follow-up, as a follow-up prompt to this output, and it will make that specific change in the output. So let's take in email template one. Can you reduce the length of the first para as and make it to the point as it seems to be long. Okay, so this is the feedback that I'm giving it on the email to the email template one. So let's see how it changes it. So besides the other part of the email, it has just focused on this section of the email. So likewise, whenever you get an output from ChatGPT, you can always specify the feedback that you want to give in the next set of prompts. So this is called as chain prompting. This further helps you improve your output. So from my experience, पहली बार में output you will never get perfect output. It will take you 85 to 90% there. So that to improve your output or take it to 95% or say 100%, you need to keep on giving it feedback. Talking about feedback, your feedback has to be very specific. It should not be a very generic feedback. The more generic your feedback is, the worse response you will get as an output. So always be specific in your feedback. Now, this is another trick to improve your output, which is called as recursion. How does it work? Let me show you an example. So this is my prompt for recursion. What it is doing is, now I'm asking ChatGPT to improve my email using a two-step process 3 times, iterating it. For example, in step one, I'll ask it to identify 2 or 3 key points, 1 to 3 key points, which are missing, and then improve the output by including those missing points. And this it will do 3 times. So let's see how the output comes out. Okay. Continue till you are done with all wishes. So in this case, it was only able to do one iteration. So I asked it to continue till you're done with all the iterations.
While it's doing, you can take the chat box questions also in between, Vipul,
Sure, sure.
if you are comfortable with that. There are a lot of questions people are asking.
We can use voice prompts as well. But see, I am personally very comfortable in writing prompts as my text because I can edit accordingly very seamlessly. Voice prompt may I need to repeat the same thing again and again. Yes. So AI can do self-prompting. What I normally do is many times what I do is when I'm not clear with my structure of prompt, I ask ChatGPT to create prompt for me by assigning it a role of a prompt engineer, say, or an expert in AI. So this can also be done. Yes. I'll show you some example on how to generate outputs which are not text. I'll show you some examples later on. I'll cover more things. I think some of the things will be repeated. So don't worry. Okay. So now what it did was at the back end, it completed all the iterations and transformed my output. Now, if you look at this output, personally, I feel this is much better than the previous outputs which were generated because I asked it to find the missing links in the outputs that it generated and improve it. So this is another way which is very useful. While this is a basic example, but in long form content, like say blogs or articles, it's a very useful technique. So do try it. So moving on, the next technique to improve your ChatGPT output is called as lever technique. I'll show you how it's done. So in this technique, what I'm going to do is I'm going to ask ChatGPT to critique my output. How it will critique? So I'll define a scale from 1 to 10, like here in this case, and I'll define the scale accordingly. For example, in this case, according to my requirement, in this case, I have defined 1 as the least professional communication, email communication, and 10 as highly professional communication. So let's see what output it generates for me. Excellent.
Do you need to motivate it in
You can
between?
do that. Yes. That's another sort of emotional stimuli. You can also blackmail it. You can also bribe it. So these are some things which work very well in ChatGPT. I keep bribing it whenever I see that the outputs are not coming perfectly. So what you can do, for example, is you can tell ChatGPT that I'll tip you uh, $10 for in case for every accurate output that you give me as per my requirement. It could be anything. It could be anything, whatever you
So,
want.
what about pattern recognition? I mean, does it recognize the way you work, like according to your style?
Yes, yes, yes. So I'll come to that. I'll come to that. I'll show you one example. So this is called as this technique is called as one shot prompting or few shot prompting, where you give some example of a template. For example, in this case, if I have some email template in mind, email example in mind, which has a proper structure as per my requirement, and I want output to be in that structure. So it can do that. All you need to do is in the E part of the RCC framework, you just put that example that whatever output that you generate, follow the structure as provided in this example. It will do that.
But
I'll show
for
you
that,
one
you have to
example.
purchase it, right? It is not available in the free version.
Free version में 4O is available. 4O is quite good, but only a few prompts are available. But
Right.
I would suggest if you are a heavy user like me,
Okay.
power user like me, then you should take at least the pro plan, sorry, at least the plus plan, ChatGPT plus plan. It's very useful. So now it has rated both the outputs. One, it has rated as 9 and 9 out of 10. It has given me reasons as well. And other one, it has rated as 9.5 out of 10. So what I'm going to do is I'm going to uh, ask it to make each output as 10 out of 10. So while it is answering, let me take some questions as well.
If you want, I can help you in telling the question.
Yeah, that would be very helpful.
Is NLP same as MLP? What is the difference?
So I have not heard about MLP, to be honest. NLP I've already explained, so I won't be able to answer this question at this stage because it's a little technical for me. I'm not a machine learning expert. I call myself as a prompt engineer. Whatever backend technology, whatever things that are neural network, for example, whatever that happens in the backend, that is not my expertise. So I won't be able to answer this question.
What
Now,
about
some
your
people are asking whether Gemini is better. Um, are they comparable or are they different,
So
completely different models?
I have used Gemini. The latest model of Gemini, which offers deep research, is one of the best tools that I've come across for research. What it does let's say if you want to do some research on a specific topic, all you need to do is give your prompt, give your topic. It will do a thorough research. It will do a Google search of around 400 links, 400 plus links. It will summarize it in a very beautiful format and it will give you an output in a Word file very beautifully. Entire summary basis its research. So ChatGPT has also introduced a similar thing very recently after Gemini launched it, which is called as deep research. I'll show you where it is. So this is available for pro users. It's not visible here. One second. I'll show you in a new window. Let me show it to you. So deep research, so this is similar to what I was telling about Gemini. It's a very useful tool for research. For copywriting, my role mainly is around copywriting. I don't think Gemini is at all comparable to ChatGPT. ChatGPT is really good. Some people say that Claude AI is very useful for copywriting, for content marketing or anything related to content. But again, ChatGPT is a jack of all trades, so I would say it will do a lot of things which Claude or Gemini might do for you as compared to Gemini and Claude. Okay. So, so it has given me an output again after using the lever technique. Sorry, not here. Let me refresh it. Hmm. Hmm. Okay, so this is the 10 out of 10 output from ChatGPT according to ChatGPT. Now, I personally again feel that it has improved the output, but again, it's a little subjective thing. But since this is a very basic example, but if you start using these techniques, recursion or lever technique, it will for sure help you in improving your output. So the next technique is this is basically a tool that is offered by ChatGPT, which is called as Canvas. I'll show you how it works. Let's take this output, for example. Now, what Canvas does is it will specifically allow you to edit certain sections of the output that it generated. For example, in this case, this is how it looks like. This section is basically Canvas. Either you can either you can ask it, open my output in Canvas, or it will directly show this option here. So what it does is it offers 4 options to you. One is to add emojis. You can specify which section do you want to add emojis in. Then if you want to add a final polish to a specific section. For example, if I want a polished subject line, then I can ask it to do that. So here it edited it. Likewise, what it also offers you is it gives you it also gives you an option to adjust the reading level. Let's say if you find that output it had generated is for an audience which are with a larger age group, with a higher age group, then you can keep the reading level a little lesser. For example, if I reduce the reading level to graduate school or a middle school, for example, a middle school. So let's see how it edits the output. So it will adjust the output to the reading level seamlessly. Now, all this you can also do while prompting with prompting, which I used to do earlier. But this canvas makes editing very, very seamless on ChatGPT. It's a very useful tool. To be honest, it was introduced a few months ago by ChatGPT. So very useful. Just, so you should try it at least once to see the impact it creates here. So if you see the output, now it has changed this output to middle school level. Likewise, you can also reduce it further to, let's say, kindergarten level. It will do it. It will do it very seamlessly. Moving on, zero shot, one shot, and few shot prompts. So the prompt that I showed you, the first prompt, I did not put any example in it. Since I did not put any example in it, I relied totally on the learning, on the training, uh, on the data that ChatGPT is trained on for the output to be generated. So this is called as zero shot prompt because I'm not giving any example to my in my prompt. So I'll show you one example how it works. I'm not sure how many of you have watched Lord of the Rings. I'm sure most of you must have watched Lord of the Rings. So there is a character in Lord of the Rings called Golem. So what I'm going to do is I'm going to ask ChatGPT to take role of Golem and interact with me. Okay. So now I've given it a role of Golem in the first two lines. And then I'm asking this question, do you want this ring? If you see the answer, very similar to how Golem speaks in Lord of the Rings. Very similar. Why? Why was it able to capture this? Because it is already trained on some data which has all the mannerisms, all the speaking style, all the tonality related to Golem uh, in that training data. I do not need to train it. Likewise, whenever you use ChatGPT or any other tool for output generation, most of the times, or I would say 90 to 95% of the times, you don't need any example at all. Your zero shot prompts work perfectly. But there will be some cases, those 5 or 10%, where you want very specific style of outputs. There, few shot prompts or one shot prompts work very well. So what do you mean by one shot prompt? When you give one example in your input prompt, then it is one shot prompt. When you give multiple examples, it is few shot prompt. I'll show you one example. I'll take questions at the end, so don't worry. You keep typing your questions in the chat.
पेशेंट्स के वास्ते बेनिफिट है तो ये हिसाब से रहता तीनों को विन 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 सिचुएशन
Case,
पेशेंट
how
को
are you
ज्यादा
doing
बर्डन
with
नहीं है
time management?
पेशेंट्स और डॉक्टर को कुछ ज्यादा फायदा नहीं थोड़ा कुछ सब फायदा है
Okay, so
विथिन
what I'm
लीगल
going to do
बॉडी
is I have
सेलिंग
an
करो चाहे
example,
अपने मेडिकल एथिक्स करो
which
ये
is
हिसाब
my one shot prompt. I'm going to ask it to rewrite that email in style of this. Okay. So let's see how it replies. If you see, the writing style has changed. For example, in the output which was previously generated, it started with dear, it ended with warm regards. It has changed because it has started capturing my example, details from my example, which is this. So this is another technique which is very useful. I hope this answers the question which was asked previously. So now I'll cover some use cases, some more use cases for you guys. The first is article summarization. So there'll be cases where you come across, I'm sure you all read a lot, specifically when it comes to medical science. Uh, you must have come across a lot of articles every day. You must come across a lot of articles every day, but due to lack of time, there'll be cases where you want a quick summary of the article without the model hallucinating. So this use case will help you in summarizing such articles very seamlessly. So what I'm going to do is I'm going to ask it to summarize an article. I'll give it a role. Let me show you this prompt. So I'm making it as an expert research assistant with deep understanding of complex topics related to medical science. And this is my text input. What I'm going to ask is I'm asking it to summarize my article, which I'm going to provide as a PDF. So as I mentioned earlier, that these models are multimodal in nature because we can give input as text as well as files. So I'm going to give a file in. So this is my article. So here, what I've done is I've given it a role. I've given it a context, instructions. These are my rules or guardrails, and article. And I've asked it to summarize it. So if you see one of the instructions, what I've asked it is to give me the exact title of the article, followed by author names. Why I mentioned this? Because whenever you use a file as an input, you should always fact check it, whether the model is hallucinating or not. You can ask specific questions. For example, you can also ask what is the exact line in the first paragraph, or what is the exact line, exact text in the third line of first paragraph, for example, just to fact check it. And once it is done, you will be clear that now it is not hallucinating. It is able to read the PDF, which is my input, accurately. So that's why I asked these two questions. Then I asked it for a short summary of 60 words and a detailed summary. Let me show you the article which I have added as an input. So this is my article, revolutionizing healthcare, exploring the latest advances in medical sciences. So let's see. So many times what happens is that whenever you ask for an output, it generates an incomplete output. So what you need to do is just type continue. Now here it has captured the exact title as it was in the PDF. These were the authors, 4 authors in the PDF, very accurately captured. This is the short summary, and this is the detailed summary which it is generating. Again, the detailed summary is being generated as per my instructions or my guardrails that I had set for it.
Vipul, you have another 7 minutes as prompted to me by our
Sure,
moderator.
sure. How you can summarize an article. Let me take you through another use case. I'll skip this. I'll show you first another use case, which is a for story writer. Okay. So what I'm going to do is I'm going to ask ChatGPT to write a story, short story for children for me. Okay. So let me write a prompt. Again, the structure is same. There is a role of an expert storyteller, context, and instructions, which are my constraints or guardrails. Okay. And I've given it a topic or a theme. what I'm asking it to do is, I'll give you a theme. You need to create a story for me, which has a moral in it. So this is the story. This is the theme that I have given it. A kid who became a doctor for unicorns. So let's see what story it generates for me. So while it is generating the story, let me show you what prompt I have added here. Story type, I've asked it to choose from a story type, whether it is inspirational or humorous or emotional. Structure I've given it. It should start with a narration, then engaging opening, and plot development and resolution, and a final moral message for the kids. Then I've asked it to use a tonality or a language which is not inappropriate for the kids. Then I've also defined some more rules. For example, voice modulation. Why I have mentioned this? Because next I'm going to use this story in another tool called as 11 Labs, which is the best AI for voice. So I'm going to feed this story there. So that's why what happens is, whenever you feed a text or a story in a text format to these AI tools which are for voice, it will not capture the modulation accurately. So that's why I added this guardrail in my input prompt so that it captures the modulation very accurately when the story is being narrated by the AI. So this is my output, for example. What I'll do is, I'll put this output in another tool called as 11 Labs. So this 11labs.io is another tool which is the best tool for voice. There are multiple sections here, a lot of things you can do, but I'll straight away go to text to speech. What it does is you just give it a text and it will generate an audio output for you. Okay. So you can choose specific voices here. For example, here I'm choosing Rachel. So let's see what it does for me.
This is the story of little Maya, who dreamed bigger than most. She wanted to become a doctor, but not just any doctor, a doctor for unicorns. Engaging. Opening. Have you ever seen a unicorn with a cold? Well, little Maya.
Now, it might sound a little robotic here. Why? Because of the voice that I have selected automatically by default. But there are a lot of voices which are specifically designed for story narration in this tool. You can choose those specific voices, and then you will see the output comes out really, really close to what humans would speak. So this is a very effective tool, very, very useful tool for storytelling. They have also launched something called as book reader, where the entire books are read by AI. So very useful. Let me show you one more use case, which is of a songwriter. So now what I'm going to do is, going to create a song which is totally sung by AI. But for that, I need a script. So for script, I'm going to chat GPT. For song, final song, which is generated by AI, I'm going to use a tool called Suno.ai. Suno as in listen. So let me show you the framework, how it works like. So this is my prompt. Again, I'm giving it a role of an expert songwriter who has won multiple awards for his work. You can add as many details as possible to the role so that ChatGPT becomes clear that what sort of role is getting assigned. Then I've given it context that I want the final lyrics to be generated based on three inputs by the user, which is topic or theme, emotion, and genre. And other rules I've defined here as instructions. Okay. So once I enter, it will ask me three questions. So all I need to do is, as user, I need to answer three questions. For example, genre, I want acoustic. Topic, doctors, are heroes with no capes, for example. And the third one is emotion. I want inspirational. So this is now it has started creating a lyrics for me, a whole song for me in a few seconds, which is quite amazing. So once my song is ready, my lyrics are ready, what I'm going to do is I'm going to feed this as an input to another tool called Suno.ai. Now here it is also suggested, given other suggestions that this is the tone that you should use. This is the voice, female voice you should use. So let me use this as an input. Mm. So this is the tool called as Suno.ai, Suno AI. Here you can see there are a lot of sections. Now I've not taken a paid version of this tool. I have some free credits left, 40 credits left. So here I'm going to put my lyrics, the entire lyrics, and the style of music. So the style of music which was suggested to me was warm, soulful, uplifting. Okay. Let me give it as an input. And I need to select create. That's it. So now it has started generating a song for me, all using AI.
It hearts they walk alone, bringing comfort far from home. Hands that heal, hearts that care, silent courage everywhere. No flashing lights, no spotlight.
So this is absolutely amazing. While my lyrics had a lot of other things like verse one, it was able to identify that which exactly is part of lyrics, which is not part of lyrics, which text is not part of lyrics. So it is intelligent enough to identify these details as well. So I'm sure that this is something that you would want to try someday. I would suggest that you highly try it. You should try it. There are other tools as well which creates songs for you. There are tools which create raps for you. I'll tell you how to search for these tools later. But before that, let me take some questions. I think there is very little time left.
Yeah, I think most of the questions have been already discussed during the lecture and we have exceeded the time.
Hmm.
So if Vikesh wants any specific questions, we can ask. Otherwise, we can go to the next speaker. Vikesh, over to you.
Yeah. So I don't have any question, but I am definitely impatient to answer a lot of queries put up by the audience related to application of AI for various activities which a pediatric surgeon come across. And I'm very sure what Vipul taught us today will take us forward in that direction. And maybe in near future, we will conduct a session where we can directly apply these techniques of using ChatGPT for our use as a pediatric surgeon or as a clinician. Thank you, Vipul, for an excellent talk and lot of hard work you did to prepare this presentation.
Thank you so much. Acha, one thing I want to add before I uh, end my part. So there is a website called as, there is an AI for that. Let me type it for you guys.
We see your this audio Suno browser right now.
Yeah. So I've just added a text in the chat box. Just check. So
Yeah.
this website has around more than 20,000, 30,000 tools, AI tools listed. Why is it very useful? Because it will give you the exact tools, AI tools which are available in the market. It will tell you whether these tools are free or paid. and for whatever requirement that you have. For example, if you type in this, if you go to this website and type song, AI for song, then it will give you list on all the popular AI tools which are available in the market and which can generate songs for you. So it is as good as this. Someone mentioned voice cloning. Voice cloning can be done today. Yes, very easily. Even video, even your AI avatar can be created. I have seen videos on social media which were totally generated by AI. All you need to do is just create your video, 2-minute video, and AI will mimic it. You just need to enter a script in text. पूरा video बन के आ जाएगा with you as a face of the video and with lip sync as well. So we don't have much time, otherwise I would have showed it to you as well. So I'm sorry, my pace was a little faster. I wanted to cover more use cases for you guys, but due to paucity of time, I need to end this workshop. Thank you so much. Thank you for your patience. I
Thank
hope
you.
this was useful to you.
Thank you, Vipul, and we will definitely engage you in future as well. Now we'll move on to the next talk, which is by another eminent speaker who has a lot of work in AI, Professor Deva Kandasamy from IAMS, New Delhi. I'll hand over to the next moderator, Dr. Ankur Mandelia, to proceed with the session. And thank you, Dr. Ramesh Babu, for giving his valuable time to us. Thank you, Vipul. Thank you, Dr. Babu.
Thank you, sir. So we move on to the next talk by Dr. Devas Sentipati Kandasamy. He's a MD from AIMS Delhi and a fellow of Royal College of Radiologists, currently working as professor at AIMS New Delhi. He has about 180 index publications and over 100 lectures and conferences and CME. His areas of interest are pediatric radiology, endocrine imaging, abdominal imaging, and imaging informatics. So we are looking forward to hearing from you on the use of artificial intelligence in imaging, specifically pediatric imaging. So the floor is all yours, Dr. Deva. Thank you very much.
Thank you so much, Ankur. We were colleagues. I don't know whether you remember
Yeah, I
me or
remember
not.
you. We trained together at AIMS. So, and we met recently, I think last year, Deva.
Yeah,
Yeah.
yeah.
So
So
looking
nice
forward to
meeting you.
hearing from you. Yeah, nice meeting you again. Thank you.
Yeah. So, yeah, first thing, I'm not an engineer or a prompt engineer. I'm just a usual radiologist, some interest in AI. And the way I understood AI when I was, maybe 4 or 5 years ago, uh, that's when the AI was slowly entering into medical field and around 2017 or 18. So it was a slow process for me because we don't understand as doctors as technicality as the engineers would understand. So I had a lot of questions. What is that? What is that? How it works? And all those things. So I've tried to retrace the same journey in my talk. So let me, all right. Hope my slide is visible.
Yes, it is. Please go ahead.
Yeah,
It is
okay,
visible.
okay.
Yeah.
Yeah. So in my next half an hour or so, I'll start with the basics of imaging, basics of AI in imaging. Since I'm a radiologist, I'll focus more on images rather than text or lab values or the clinical things. But it is easy to extrapolate the same techniques or same the principles behind any of these AIs in imaging into the clinical field also. Another thing which I wanted to tell you is that imaging or anything to do with children is little the data is less for anything to do with children. So the AI currently which are available in the market mostly for the adult patients. So but that will change. It will trickle into pediatric surgery and things like that. So it will take some time. Definitely it is going to come. It is in the right direction now. So that's what. So when I started learning about AI, the first thing which occurred to me was what is artificial intelligence? It's the same as automation. We have multiple automated things in our life. When you enter a room, the light comes on. When the tank is empty, the water pump starts on its own. So is it same as AI, or what is this? What is the difference between automation and AI? And then this is how I generally give an example that let's consider a light bulb. You just want to your light bulb, when you enter the office, the light bulb should go on. And normally what we do is we enter the office, we switch on the light, and it comes on, and we get out of the office, you switch it off. That's the usual manual operation. But what is automation is that you set a timer. There can be a sensor like a light sensor, a motion sensor, whatever is there. The sensor will figure out the day and time of day, the time of the day, or the movement of any person inside the room. So these are automations. There's no, the real intelligence in it. Then what is AI? In the same light bulb analogy, if you want to fit AI into this is how I would imagine. So you'll have to teach the bulb that what is the time of the day, what is the day of the week you enter the office, and what's the usual timing of lunch break or coffee break, or when you leave the office. So over a period of time, in a month or so, the AI will collect a lot of data about your movements in the room. And after that, it will know that this is the time you will enter the office, this is the time you will sit in the office, this is the time you'll probably go out for lunch. So all this data will be learned by the AI. And after a month or so, once it has enough amount of data, it will work perfectly according to your routine work. So this is artificial intelligence. In the modern artificial intelligence is completely based on the data which is available, and that framework or the algorithm learns from the data. So that's the reason data is very important. Whenever you want to do something in AI, the first thing the data and scientists would ask you is how much data you have. So because it is not complete coding. You cannot code everything, each and everything. Like Vipul showed us, that you cannot possibly code each and every responses like it did in the last lecture. So the data is the driver. The uh, uh, the tool learns from the data. So what we need to have is a lot of data to supply to the algorithm so that it can learn. So that's the light bulb analogy, just to show you what is the difference between the automation and AI. Because many doctors will have this difficulty in understanding the difference between the two. So AI is not a new word. It was coined in 1950s. Back then, it was just a concept. Now it has been a reality. So if you go little back in 1990s, this is how the AI evolved, or the machine learning or the deep learning evolved over a period of time. So in 1992, there was a game. It was a Chinese checkers game, which happened between Chinook. Chinook is a computer, and Maureen Tinsley was a checker player. And in 1992, the computers were very, less computationally able, and the GPUs were not there. So the computers were not that great in winning a game over a human performer. So Chinook lost to Marion Tinsley. But in 1997, you would remember this event, because it was a game between Deep Blue, which is again a computer developed algorithm developed by IBM back then, which played chess game against Gary Kasparov in 1997, and Deep Blue won that match. So people were, even then, people were not very convinced that, chess is a game where there are only finite number of moves. You can calculate all those moves. You can code an algorithm to play chess. So people were not very impressed that, still human performance is better than computer performance. Yeah, but still, Kasparov was a grandmaster, a champion player who was defeated by the Deep Blue, which was not even current generation computer. It was 1997. So things changed dramatically when this thing happened in 2016. AlphaGo was again a computer algorithm which was trained to play a game called Go. I don't know how to play Go. Go is a game where it's a board game. The number of options for each move you can make is in the order of 10 to the power 360 options you have. Whenever you want to play a move, the options you have is, huge number of options. You cannot possibly code all these scenarios or movements or the options into your coding algorithm, right? It's not humanly possible. So what they did is that they trained and they showed multiple games of AI. I'm sorry, multiple games of Go to this particular algorithm, and that the company which was behind this algorithm is DeepMind, now is a part of Google now. So and once it became an expert in the particular game called Go. The event happened in 2016, and Lee Sedol was the player. Again, he is a champion player of Go, and he was defeated convincingly by 4 versus 1, which is a very significant thing if you follow that tournament. So this is when people realize that the EA has that capability of cognitive analysis, superhuman capabilities, and in a game where there are options of 10 to the power something. If something can beat a human, and we always boasted that human capability or human intuition is something different, which computers or an algorithm cannot match, but that is slowly changing now. And the reason behind this significant change is something called deep neural networks. And because AI has been there for a very long time, but the thing which changed this whole thing over the last 7 years or 10 years is the neural networks and the chat and the GPTs, the transformers. So it made all the difference in the evolution of AI. It was considered as a disruptive technology like invention of electricity or internet. The way electricity and internet disrupted our life is similar way AI is going to do it in the future. That's what people expect. And the thing is that it learns from the data. You don't need to code for anything. If you want, if you compare a calculator or a simple computer versus AI algorithm, the difference is that for a calculator there are codes and things which are written in the firmware, and that is how the calculator works. But the AI algorithm learns from the data by itself, and then it performs according to the data and you expect. So this is a terminology I want to just explain that AI is a broad term. AI constitutes everything, right from whatever has been there since 1970s or 80s. So AI is a very broad umbrella terminology within which there is a sophisticated thing called machine learning. Machine learning is you give data, and so the algorithm can learn and produce valuable results. We use in a lot of our researches. Machine learning is used in radiomics and other imaging researches, and within that there is a much more sophisticated thing called neural networks. Neural networks are the things which are currently in utility, and these chat GPTs and transformers are all fall under this particular more sophisticated part of artificial intelligence. So artificial intelligence is a very broad terminology. So more specific terminology to address these tools are deep learning networks or neural networks or GPTs. All right. So if you compare traditional AI or traditional method of artificial intelligence or a modern method of artificial intelligence, what is the difference? As I told you, the traditional methods would require explicit programming. For example, I'll just give an example. It was a simple example that uh, if you give the computer that x equal to 1, and you should give the rule also that y is twice that of the x, then the computer would give you the answer of y, because you are giving the data, you are giving the rule also. Whereas in the modern neural networks, what happens is that you just have to give the data. You just have to give that x equal to 1 and y is equal to 2. And another data of x equal to 2 and y is equal to 4. You don't have to give the rule to the computer. It derives a rule. It understands the relation between the two data, and by itself it understands the formula, and it knows that y is nothing but x to twice of x. So this is the difference between the traditional algorithms and the current generation algorithms. It learns the relationships. It learns the possibilities based on the provided data, and that's the reason why data is important in artificial intelligence. And if you look at these performances, the traditional algorithm would perform right from the first day, right? Just once the coding is ready, when you start using it, it would perfectly work well. Like like calculators, you don't have to train them. You just start calculating, it will do it from the right day one, right? So it performs from the right day one, and but after that, it is the performance is going to be the same. Whereas in deep neural networks and gpts, what happens is that it learns over a period of time, and once it matures, the performance will be much better than the traditional methods of ai. So that's the difference. Just a minute, my slides are not moving.
Deva, due to lack of time,
All
can
right,
we move specifically to the image AI
right,
in imaging part?
right.
Uh,
I'll skip my
yeah,
slides
though all
and
of this is very, very useful and informative,
all right.
due to lack of time, if
I
you can
understand. I understand.
specifically move to the AI in imaging part. Thank you.
Absolutely.
Yeah, yeah.
Absolutely. I'll show some imaging related things, and then
Sure,
I'll
sure.
show some things which what we do and we do in our department. All right.
Yeah, absolutely.
So yeah. So, specifically to imaging, what happens is that even sometimes the computers can generate images. What is the utility of this? It can generate chest X-ray, it can generate MRIs, it can generate CTs. This will be helpful in places where you don't have enough data. You can generate your own data, like in rare diseases, it can generate data based on the available literature and everything. And one utility of generating image is this. For example, if you have a lumbar spine a CT scan, MR can generate, sorry, the algorithm or the AI can generate MR images of the same. So you don't need to perform the MR. You just based on the CT and CT data, the algorithm can generate MRI images. This is very important in pediatric age group where radiation is a problem, and MRI is also getting MR in a child is also a problem because it needs sedation everything. So either ways, if you have a MR data, you can create CT without giving radiation, or if you have a CT data, you can create MR so that you don't have to sedate the child to get an MR done. So I'll just come to our experience with AI tool. Is that this is one tool which we use in our department. So earlier, when we want to use radiographs to estimate bone age, we have to use either the TWT method or the GP method, where you have to manually look at those atlases and fix the bone age. So it used to take 10 to 15 minutes, and it's very intensive task. And for a learner, it's very difficult to use that tool. So this particular automated bone age estimation is a AI-based tool where you just have to upload the image. There is a tool. It's a software, and you just have to upload the image, and it will give you the bone age estimation. For example, this is one example of the X-ray which was read by that particular AI, and it will just map out all the bones in the hand, and it will understand the pattern, the fusion process, the shape of the bones, and everything, and it gives you the bone age. So this is one utility which we use in our department routinely nowadays, because it reduces our time to manually calculate the bone age. So this is another tool which we use in our department. This is again a commercial tool. The last slide was also a commercial tool, and this is also a commercially available tool. These commercial tools are very easy to use. It sits in the background. It is connected to our packs. We have a packs where we store all our images which are generated in our department, and it talks to the packs. It fetches the images from packs. It analyzes it. It sends it back to the packs with the report and with the annotations. And when the radiologist or our residents look at those images, they will already have this reports of the AI alongside when they report the X-rays. For example, this is one X-ray which was read by the AI, and AI feels that this is a normal, and I also feel this is a normal chest X-ray of the child, and this was reported as normal. All right. Now, this is another example where this was also reported by AI, and now I mean, it looks normal. Just there is subtle shift of the mediastinum. Maybe that's because of the rotation, but still there is shift of trachea. So it correctly identifies that as tracheal shift, and it is a good pickup as far as I'm concerned. And this is another example where child had ascites. There is, abdominal distension was there. So that's the reason why there was some effusion and there is some atelectasis in the bilateral lower lobes. And the AI was able to find out those the abnormalities and also mark out those abnormalities. It is also important to mark out, right? So the tool does that for us. So it marks out the area of abnormality. This is again a child with bilateral, consolidation or atelectasis and effusion in the lower lobes. Another example, again, infiltrates in the upper lobe, middle lobe, and in the left side also. And it clearly marks out all those abnormal areas. Sometimes not everything is perfect with these AIs. Sometimes it can give a wrong report also. This is again that commercial AI tool which you use, and it said that there is some opacity here and there is some opacity here, but there is actually nothing. So it can only be used as a screening tool. First read can be by the AI, and the second read can be by the resident or the reporting radiologist. So, 9 out of 10 times it will perform okay, but there will be 1% or, that one time where it may go wrong. So there has to be a second check. As of now, these algorithms are not independent. They are not matured enough to give you the final diagnosis, but definitely they can screen, and it can make your effort much less. This is another tool which will tell you whether there is a fracture or not. It correctly identifies the fracture site, although it's very subtle. There are a lot of artifacts. The cast is there. There is post-op things. The nails are there, but still, it was able to figure out that there is a fracture in that side area and mark that area with the bounding box. All right. So here on I'll show our experience, our own experience. This was the earlier 2-3 examples were from the commercial softwares which we use in our department. Here on I'll tell you our own experience and the tools developed by us in our to help our practice. So, during the COVID, we also thought that we should develop some tool to differentiate COVID X-rays from non-COVID X-rays, and this was the output of those tools, that the algorithm was able to figure out the area of the abnormality and would say that this is the area of the abnormality and this looks like COVID positive X-rays. But the interesting thing is that some of the patients, it kept on showing the area in the heart as abnormal, whereas we all know that COVID mainly involves the lung, whereas it was kept on pointing out the area of the heart, where we think that there is nothing in the heart, there is no heart, there is no lung in this area. So why is it pointing out these areas abnormal? Then later on, we realized that all these patients where there the pointing out the heat maps were in the heart also had cardiac failure. That's because of the COVID involvement of the myocarditis. COVID myocarditis leading to cardiac failure. So sometimes it may pick up things which we don't understand, which we don't.
अगले महीने
It
सबसे
is not
ऊपर
apparent.
लिखा है
So
अगले महीने
sometimes it
होने
can
वाला
go
है
wrong. Sometimes it can go
सबसे
wrong.
ऊपर
Sometimes it can pick up things better than us. So the combination of human and the AI as of now is the best combo. The first read should be by the AI and the second read should by the human reader, so that you don't, you have best of both worlds. So this is another example where we used, this is not the modern AI. This is something called radiomics, which is based on machine learning methods, little, older generation of these artificial intelligence methods, where we wanted to differentiate just by marking the ROI on the particular tumor here to say whether this is what this type of RCC is. We know this is RCC, but what kind of RCC or renal cell carcinoma it is. So by doing this analysis, and we got to know that the radiomics utility can differentiate the several histological types, subtypes of RCC. There is another again a tool which we generated, which is again available in the GitHub. Is this was done in collaboration with IIT Delhi, and in this tool, what we try to do is that in patients with osteosarcoma, just after giving the first course of chemotherapy, we wanted to know whether that patient responded to treatment or not. So we use this machine learning algorithm to figure out that. So otherwise, normally what we do is we wait for all the cycles to complete and do a scan to measure the size reduction which has happened after finishing the chemotherapy. But what we try to do is that just after finishing the first chemotherapy, we wanted to know whether this patient is going to respond to chemotherapy or not. And we were able to figure out that by using this machine learning tools, that just after finishing the first course of chemotherapy, we would know that whether this patient is going to benefit from chemotherapy, or if it is not, if the patient is not going to benefit, you might have to change the chemotherapy or change the line of management. So this was one utility which is there in the GitHub also now. And there is another utility which we are actually in the process of development, is that we wanted to segment lung nodules on CT scans. And you all know that the picking up of lung nodules is not so difficult on CT scan, but segment it out. Segmentation is nothing but marking out those areas on those CT scan so that you create a volume of that particular nodule in the lung. So this is this blue color area and this red color area marked as a segmented nodule here. So what this particular tool does is that you just have to pinpoint that tool by putting a cursor on that particular area. The tool automatically segment the nodule. If I'll show other example, you just have to keep a pointer here and click it, and the tool will automatically a segment out that particular nodule, and it will be saved as a particular, it can be saved in a separate file. So the utility of this is that whenever we want to study the nodule characteristics, and we want to see the size difference in the nodule between the two scans after chemotherapy or before chemotherapy, you have to know the volume and other metrics of the nodule. So you will be able to get the metrics only if you segment out the nodule. So the segmentation is a tedious process. Otherwise, you would have to mark that outline at every level, in multiple slices. It's a very tedious process. But this particular tool is again machine learning tool, which will easily get it done for you. So this is another example of a child with a nodule. You just have to put a pointer and it will correctly segment out that particular nodule for you. So this is our experience with AI, and our experience with AI is that it really helps in our workflow. It reduces the time to report a chest X-ray because we do almost 500 exercises in a day in our hospital, and it is not possible for our residents to report all those chest X-rays. So what we do is we pass through them through the AI first, and AI will divide that into normal and abnormal X-rays, and only those abnormal X-rays are being reported by the radiologist. The normal X-rays are directly sent to the clinicians. So this is one utility which we feel that is good because it reduces the turnaround time for those X-ray reports. All is not good in AI because there are areas where AI is not okay. It is very difficult to trust the AI, especially in imaging. There is something called black box problem in AI. The reason what is this black box is that we don't know why AI decided that this is normal or abnormal. It will not give any explanation. There are efforts currently which is going on, which
आजकल
is
एआई
something
को
called
खूब लेक्चर चल रहे हैं
which is something called explainable AI. There are multiple efforts around the world just to make the AI to explain why it decided and what is the
Screen
explanation
start
of that
calculator.
decision. But otherwise, as of now, what is the problem now is that it will show an area that is abnormal or normal, but you will not get to know why it said it is abnormal. So this is the black box problem. What what is happening behind the inside the box is not clearly understood. So that's where we need to. Why that is important is that, if you cannot, as a pediatric surgeon, you cannot operate on a patient that this AI said that this patient needs to be operated. It is not possible. You need to understand why it said, and is there a reason why, is there a logic to that decision, is there a evidence for the decision, that we need to know. So that is currently that is missing. So that's a reason AI cannot be fully trusted. There has to be a human reader, or a human which has to who has to read and understand, and then decide on that particular decision. So I'll not spend more on this. Yeah, you cannot follow the AI blindly, because these are those can be, they are prone to fatal errors. And if something goes wrong, I mean, there is, whether the user or the company or the algorithm who is at fault, there is no clear legal provisions for that as of now. As of now, the radiologist who will sign on that AI generated report is the person who is responsible. That's the current understanding, but in future it may change. So it is we can use AI, but someone has to cover it or screen it. So for pediatric surgeons, there are few tools which are available for children as of now, but definitely it's going to change, because there are many startups who are working on chest X-rays, ultrasound, all aspects of imaging. And I'm sure it is happening. The same is happening in the clinical aspect also, and in the laboratory aspect also. There are multiple clinical decision softwares which are also available. So it will come up. It will it's all why the pediatric related AIs are less in the market is that the data is less. The availability of data is a problem. So that's the reason it takes time for them to develop. And the That's the reason why the adult related imaging AIs are much more widely available. Commercially available tools are very easy to use, and you don't have to do anything. It is like uploading an image to the AI, it will give you the report. So there is no prompt, or there is no need for anything you need to construct or anything. You just have to upload the chest X-ray to the algorithm. It will give you the report with all those annotations and text reports. So there is very little you need to do when you are using a commercial AI, because they are very matured and easy to use. Uh, Sometimes, a particular process. For example, some AI must be maybe great in picking up the lines and tubes on chest X-ray, whereas the other AI is good in picking up the other abnormalities like pneumothorax or consolidation or effusion on the radiograph. So nowadays you can use those two AIs simultaneously, or you can tell the framework that if you find any tubes or anything in the chest X-ray, that particular AI will report. If it is not, this particular number two AI will report. So you can configure any of these things on the frameworks. These frameworks are available, so you just have to buy those AI subscriptions and plug in into your framework, so that multiple AIs can work on every many aspects of imaging. So it's all possible now, but they're and easy to use. But if you're interested in developing a AI tool, that's where you have to put a lot of effort. But otherwise, using already commercially available AI is very easy, and it's not difficult. But if you want to develop something, it is little time consuming, and it needs a lot of effort. You have to figure out an area of need. For example, when we wanted to develop something for our own purpose, our area of need was to report an X-ray which is normal or abnormal. That was our need. Our need was to classify a normal X-ray from the abnormal X-ray, because the numbers were very difficult to manage, and we just wanted to separate the normals from abnormal, so the normals can go without any report. So that was our area of need. So similarly, you have to figure out the area of your need and the niche area where you need to develop something and get assistance from AI. Once you figured out that area, you need to strategize. And you need to strategize. So
Sorry.
so and you have to fit that particular workflow, particular tool into a workflow. For example, maybe I have a very good AI tool, but it will not work in your packs or in your workflow, in your routine reporting. Then it is not that useful. No one will take out the X-ray, copy it in a pen drive, and use it in a separate computer. Even though it is great or anything, it is very difficult when you have to copy those things and transfer it on those. So it has to fit in your workflow. Though we are used to a particular workflow as of now, so the AI tool should be able to integrate within our existing workflow. Otherwise, the any tool which you will develop, it won't be. The people won't use it as much. And once you have this idea, the area of need, you just have to strategize and start collecting the data. The data is the most difficult part in developing any AI. If you want to do something in ultrasound of bladder, you have to collect thousands of images of bladder ultrasound, and you have to give examples, and you should have representation from every aspect of the abnormality. For example, if you want to develop an AI for genetogram, or develop an AI tool for MCU or RGU, you should have representation for all the anomalies and abnormalities, so that the AI will have the knowledge of all those things. It is like teaching a resident. You're developing AI is like teaching a resident. You just have to give data, give examples, show the examples, teach the resident. That's how you teach the resident. Similarly, the development of AI is also the same. You just have to give data, let the machine algorithm learn and mature. And once it learns and got the hang of it, it will perform like a consultant. That's the whole process of developing AI. And another important aspect is that you need to have a good data scientist, and who can develop a good UI and UX for your tool. Otherwise, if the tool is not looking great and then the UI or the user interface is not great, you will not be. That won't be that useful because people won't use it that much. So this is what I would recommend, that you should figure out an area, work on it, strategize, and get people who can do it, data scientists and the UX developer, and you can successfully develop a tool. The key here is data, which is the key, which is the most time consuming process, and annotating the data is also very time consuming. So that's a bottleneck of developing any AI tool. So this is my conclusion slide, that AI domain is exploding. As of now, it's not nothing much is available in the pediatric surgery arena, but it will change. It'll come sooner or later. It will be there in pediatric surgery arena also, and it is important for us to keep tab of what is going on in the area of AI, because unless you get used to those tools and get used to those workflow, you will be outdated. You will be in another 5 years or 10 years, there will be a lot of AI tools which will be available in our workflow. So unless you get used to those workflows and AIs, you will get quickly outdated. And that's the reason we have to keep tab, and we have to learn things, how they work and what's the basis, and what is all available in the AI arena. And data is the basic requirement for any AI. So when you want to develop something, you have to start with data. So that's the important message. And I think that's it from my side. If you have any questions, I'll be happy to answer those.
Yeah, thank you, Deva, for an excellent talk. And so, one question I have is are there any commercially available AI tools already incorporated in the current CT and MRI machines which are being marketed? Like
Yeah.
you said about the X-ray, but
Yes.
also are they already incorporated or still in the developmental phase? You can highlight that.
It is already there. It is already there.
Already
I'll
there.
because those are not visible to directly visible to us because we are not routinely using it as an interface area.
Yeah.
Most of the companies have their own AI-based reconstructions. They'll have multiple names to it. For example, Deep Boost or Deep Resolve, which are there in most of our scanners. It is not visible to us, but when the images are generated from a raw data to visible image, what we interpret is all generated by AI nowadays. What is the utility of those algorithms? The utility of those algorithms is to reduce the radiation dose. So when you reduce the radiation dose, there will be a lot of noise which will occur uh, in the in the images. So those reconstruction algorithms, AI-based reconstruction algorithms, are used to reduce the noise. So once you are able to reduce the noise, you can give less radiation and achieve the same level of image quality. So
Yeah,
when the
I
images
meant
are
also to reduce the time in your reporting. Like as you said, like for
yes,
X-rays, for CT and MRI, say it shows you the areas of concern like nodules on the lung or say
absolutely,
vascular involvement, etc. So that when you report, the time taken for that is reduced and it is already incorporated in your packs and the tools are already there. Like you can just use them and
absolutely there.
report them. Like yeah.
Absolutely, it is there, but they are in bits and pieces. It cannot completely read chest CT in
Okay.
all aspects. Looking at all the aspects. As of now, that is not possible. But there are specific tools like it can pick up the lung nodules. It can pick
Okay.
up pneumothorax. It can quantify the ILD. If you are dealing with ILD, it can quantify the ILD. So those kind
Okay.
of tools are available, but they are not, they are in bits and pieces, task based. They are specific use case scenarios where you can use
Yeah.
AI, but you cannot. There is nothing available which can tell you that it will read the entire CT or MR and it will tell you what all the findings there are. It is not there. But
Okay.
I don't think it is. Once these small bits and pieces are being developed, there will be a meta AI which will combine all those capabilities, and maybe in future there will be a single tool or single algorithm which will read the entire chess CT and give you the answer. So currently these
Yeah.
are specific area based, not as a general CT.
Okay. Also, there are a lot of questions in the chat box about the accuracy of these tools. Like, say, for you said about bone age on the X-ray. So in your
Yes.
opinion, how accurate are they currently? Like around 90%, or what is the figure in your mind when you see the X-rays,
They are
the
they
say
are
for bone
they are
age?
good. They
Yeah.
are good because that's the reason they are commercially available. They have this a regulatory authority clearances also, and we also feel
Okay.
that it's very accurate. So there is no issue uh, in using them at all because they are approved by multiple regulatory.
Okay.
Um, yeah.
Another area where I think this imaging, AI imaging will reporting will get incorporated with pediatric surgery is where the imaging is now transposed on live images on the laparoscopy or robotic platform,
Yes.
and the AI is actually guiding that image-based guidance for navigation during surgery. So I
Yes.
think that is a cusp of imaging and pediatric surgery or surgery in general.
Yes, absolutely, you are right.
Yeah,
Virtual navigation, or you can overlap you can
yeah,
overlap imaging on the laparoscopic videos. Also, just by looking at the laparoscopic videos, the AI can mark out the anatomy. For
yeah,
example, this is something which I've seen in laparoscopic cholecystectomy surgeries. There is a tool which will
yeah,
constantly mark out the areas where the gallbladder is located, where the CBD is located, and where the cystic duct is located. So for the user, irrespective of the angle of view or whatever it is, the anatomy is clearly marked. For
yeah.
for a senior surgeon or an experienced surgeon, it may not be of help, but somebody who is starting his career, it can definitely easier if something is marked out that this is
Mm,
something which you should not touch. red
Yeah,
areas and green
it's in
areas.
real time, and also the new robotic platform by Intuitive. It also integrates the CT. Say you're operating on a difficult malignancy, and so for navigation in real time, some of it is now already commercially available, though
Absolutely.
maybe not in India. But I think in the coming few years it will be a big help during surgery using laparoscopy or robotics.
Yeah.
So.
Yeah.
I think we have covered most of the areas. Dr. Vikesh, if any other questions or anybody wants to speak.
Firstly, thank you very much, Deva, for your enlightening talk, and especially like the applied aspect of radionomics and use of AI in imaging. Uh, just for the benefit of the audience, I have meanwhile created two examples on ChatGPT. I know it is not very accurate. Let us not reject everything if it is not accurate, but it is sometimes very useful. I show you one example here. Like uploaded an image of a chest X-ray, and I have written a prompt, a very short, quickly written prompt. Interpret this chest X-ray in an Indian patient with cough, fever, and weight loss. So putting the history and the X-ray, I get to know the findings of the X-ray, which are very well described by ChatGPT. And one more point I would like to add here is that your own subscription of ChatGPT learns as you use ChatGPT more and more often. So it is basically that learning process of the personalized ChatGPT is happening. So if you use it like once upon a time, then it's not going to be so accurate. But if you start using it continuously, your chat GPT learns and it starts providing your answers according to your requirement. Now, as you can see, it is showing at times it shows a lot of differential diagnosis also. I'll show one more example. Like I used it before, here I just did it hurriedly. I uploaded an histopathology image with ISC staining CD31 areas, and I just told ChatGPT to mark those areas or generate an image. So it generated an absurd AI generated image, which is of no use. So I corrected my prompt and asked it to mark positive areas in the uploaded image. Now, as you can see this image, can you appreciate this image on the right side? It has marked the CD31 positive areas. So this is how, like, there are a lot of applications and it need to be explored. We can't just simply reject AI. I know it is very flawed, but as it comes like with more perfection in future, we need to learn from today. And that was the objective of creating these sessions. This is what Ankur I wanted to show. Thank you.
Yeah,
Absolutely,
thank you,
sir. I
sir.
agree.
Yeah,
I agree
yeah,
with
they
you
were going.
because that's the reason that the first read for anything can be AI and the second read can be the human radiologist or pathologist, whoever it is. So, bulk of our mundane tasks are completed and done and dusted by the AI, and you just look at the cream of the issues, decide, yeah, is right or wrong. That's the kind of thing. Yeah, thank you.
I think we can move to the next session, sir. The
Yeah.
time is limited.
Thank
So
you,
thank you,
Ankur.
Deva. Thank you for an excellent
Thanks,
talk and
thanks,
enlightening
thanks, thanks,
us. Thank
Ankur.
you so much.
Thank
Thank you.
you. Bye.
Thank you. Thank
Bye
you.
bye.
Now we'll move on to our own Vinayak Rengan, who has at his very young age has done a lot of work on AI, and he seems to be one of the most promising person in Indian Association of Pediatric Surgeons, who will take forward our dream of using artificial intelligence in various fields of pediatric surgery, which I normally stress to everyone is like for clinicians, for researchers, for students, and for patients, and especially for at last for the association also. So I hand it over to our moderator, Dr. Gurmeet Singh, who has taken a special training in AI as an expert. He's going to sit in this session, and Dr. Vinayak Rengan, over to you for your talk.
Thank you so much, sir. Thank you, Vikesh, sir. Now, I would like to introduce everybody with Dr. Vinayak Rega. He is a pediatric surgeon in making. He's doing his MCH residency in pediatric surgery at SMS Jaipur and is an adjunct faculty at Medical Imaging and Reconstruction Lab in the Department of Engineering Design at IIT Madras. He is an international presentations in Europe and US on applied AI in surgery, and he had multiple publications on AI in surgery and surgical radiology. So I would like to welcome him, and he is a part of our mission for intelligent augmentation for pediatric surgeon. That is a motto that has been given by Vikesh sir, and it is a part of this first online workshop for the beginners. So over to Dr. Vinayak for this presentation.
Thank you so much, sir. I think Vikesh sir and Gurmeet sir, you have been very kind. So, can you see my screens?
Yeah, we can see that.
Yeah. So, I'm a surgeon. I am not an engineer. And I am in my last few months of my MCH pediatric surgery residency at SMS Medical College, Jaipur. And the dream for my interest in AI started off way back in 2016 when I was a first year MS General Surgery resident at Madras Medical College. It started off by understanding it started from a very socialistic perspective, to be honest. And I was seeing patients being operated by SRs, by assistant professors, and by the professors. And I used to feel, it's just a matter of luck who gets operated by the best surgeon. And the results, outcomes were extremely varied. At one end of the spectrum, you could see a lab colleague being, demonstrated with absolute perfection, the critical view of safety being demonstrated, and the entire surgery getting over in less than 1 hour, however difficult the gallbladder is. And at the other end of the spectrum, you would see very simple gallbladders being complicated by inexperienced surgeons, bile duct injuries. And for me, that was a major issue because I used to feel, these things can't be left to nature. This is a matter of luck who the professor operates on and who the SR operates on. And the nature of training is such that at some point of time, all of us residents, everyone has to operate. And my intention was very clear. How do I bridge this gap? And that's when I started reading about AI. And in 2016, it was very primitive. To be honest, all the people whom I spoke to kind of said, what are you thinking about? It's not even possible to bring in AI into actual surgical field. So it started off with a very simple project. And this is one of my favorite images. It's just a surgeon contemplating. And this is a AI generated image as the talk of the theme goes on. It's a image of a surgeon as imagined by Picasso. So problems are everywhere. And at every aspect of surgery, we see some sort of a problem. We face problems during Duhamels. We face problems during tracheal TEF repair. You will find it difficult to identify the esophagus. Some people find it very easily. Some people find it difficult. You might want to identify the vagus nerve. You might want to, any structure you want to identify, you face some issues. You face issues in decision making. You look at a X-ray. You want to identify where the fistula is an anorectal malformation. You find some difficulty. So the problems are everywhere. It's just that some people are smart enough to identify and try to solve them. So how do we solve them? I think Dr. Deva spoke a lot about radiology. I'll be just showing you a little bit of how we have applied radiology in surgery, pediatric surgery especially. Then there is computer vision, which is my area of expertise. Then how do we use machine learning to predict outcomes? And then of course, generative AI. Generative AI is being covered by Vipul in the first talk. So the radiology, I'm not going to expand too much because Dr. Deva has spoken about it in detail. But now this is very similar to a dog. Don't mistake me, I'm not calling anyone a dog, but a dog is able to hear frequencies which are way beyond human comprehension. So when a algorithm looks at a image, the amount of processing which it does is way beyond what a human can process. And that's what Deva sir told in his talk. When you're looking at a black box problem, we really don't know how it is able to derive outcomes. So this is some of the ways when we are one of the big advantages of using AI because it is able to perform tasks which a human is not able to. So like I always like to say, it augments human intelligence. It's not just artificial intelligence, it's augmenting intelligence. So the entire revolution started off with the ChexNet algorithm. This was way back about more than 15, 20 years ago. This was at Stanford. Pranav Rajpurkar trained an algorithm on X-rays. These were actually pediatric X-rays. They started off with pediatric X-rays to detect pneumonia, and in the Northeast. And they found that thousands of children in India die because they are not able to access IV medications on time if they are having pneumonia. You have a chest infection. If you have a pneumonia, they refer it from the peripheral center to the tertiary center where they can be admitted and treated. And when they actually trained the algorithms on thousands of images, they were able to, using convolutional neural networks, they were able to create an algorithm. This is way back. This is way before the LLM revolution and everything. They were able to create an algorithm which was able to perform much better than human radiologists with almost 85% accuracy. So I'm not going to get into the details of what an F1 score is. but they used a convolutional neural network, which is still being used today. So pediatric risk structures. Similar problem. You are unable to identify injuries in pediatric radiology because the fusion of the bones does not happen. So they were found that fracture detection. This was way back in 2023. It feels funny, but we are at this point of time we are saying way back in 2023 because in last 2 to 3 years things have changed rapidly. They've been able to find that fracture detection in pediatric wrist trauma x-rays, sometimes it performs better than even radiologists or orthopedic surgeons. Brain tumor segmentation. To identify the exact area where the brain tumor is, to differentiate between the brain tumor and cerebral edema is something which AI has proved to be pretty efficient in doing. Something now very interesting to us. This was a paper published in 2020, and this has been actually commercialized by a company called AIDoc. What they have created is a triage algorithm. Say, for example, 200 CT scans are being performed in a very high volume center. And the usual reporting time in the West is, say, 1 to 2 weeks. But you don't want to miss out any child with appendicitis. So using principles of radiomics or AI and radiology, with Dr. Deva explained, algorithms have been trained to identify appendicitis in X-ray, in CT scans. And those CT scans are alone referred to the radiologist for early reporting. So the AI goes through the algorithms, tags, okay, this appears like an emergency. So it tags appendicitis, it tags a pneumoperitoneum, it tags up, cases where there is significant bowel wall edema or any other warning sign. And then those are the CT scans which are actually reported by the radiologist in the first few hours so that you don't miss out a child with appendicitis and that doesn't go in for perforation. So this is an algorithm which we have developed. My team has developed. This is a ventral hernia. And one challenge which we found when we were talking to surgeons in complex abdominal wall repair is that they were unable to find the mesh. The entire purpose of a ventral hernia mesh is that it integrates into human tissue. Okay. And a human kind of finds it very difficult to identify the mesh on a CT scan because it has integrated really well. So if you look at this CT scan, the mesh has been identified with a reasonable amount of accuracy. It is able to differentiate between layers of the abdominal wall, the muscle layers, the peritoneum, the fascia, and the mesh. And this is something which humans kind of find it difficult to do it. And there are a lot of parameters. So when we trained our algorithms, we were able to find out that the algorithms in ventral hernia, postoperative ventral hernia cases, they were able to even find out what kind of surgery was being performed. And when we deep dive into it, we realized that when a surgeon is performing a retrorectus repair, the physiological interrectus distance is decreased, is obliterated. And this was detected by the AI. And this was not something which we trained the AI to do. We didn't tell the AI that, the physiological interrectus distance is decreased in a retrorectus repair. And this was something the AI was able to perform. So again, now this is a little more difficult case. And we were trying to identify the mesh. And the mesh was able to identify. We wrote even a chapter. The publication is also pending. The recent IAG's manual of hernia. There's a chapter by me where we have spoken about how we have been able to use AI in ventral hernia repairs. So another use in ventral hernia which we created was we were able to identify the volume, not just of the abdominal sac, but also the abdominal volume. So this was useful in identifying something called as a Tanaka index, which is basically the ratio of the sac volume to the abdominal volume. So I'll just dive into something which is more interesting for us. So machine learning algorithms have been able to clearly tell you what could happen in this particular patient, essentially aiding in decision making. So it essentially works by recognizing data patterns. So how do I explain machine learning? Machine learning is a very simple concept. It is essentially statistics on steroids. So in statistics, if you're able to analyze, say, 10 variables, 20 variables, in machine learning, you are able to analyze hundreds of thousands of variables and try to figure out patterns. So if you are able to enter the symptoms of a patient and the algorithm is able to identify, say, a condition. So for example, in neonatal jaundice, about 43 different blood parameters and patient parameters were entered and trained on an algorithm. And what they found, this was published in 2020 in Frontiers in Pediatrics, and they found out that the machine learning algorithm was much better than even a clinician, a pediatric surgeon, in identifying whether this is biliary atresia, whether this is physiological jaundice, or whether this is neonatal hepatitis. So I think that is phenomenal because you are able to actually avoid a biopsy in this patient and try to counsel the patients and maybe plan for a surgery without even going for a liver biopsy. So again, there have been multiple amount of publications, especially in the pediatric cases in pediatric appendicitis, whether this particular patient is having appendicitis or whether it is whether it is something else. And these algorithms have been developed on either CT scans, ultrasounds, or even just clinical parameters. Say the patient, you record the patient's symptoms in an algorithm, and we are able to identify
20 minutes, 30 minutes.
where we are able to identify whether this is actually appendicitis or not. Now, this could be of great use in a setting where there is no emergency pediatric surgeon. There is maybe an emergency physician who is sitting and he's confused whether this is appendicitis or not, whether to call the surgeon for immediate surgery or not. And these are algorithms which can save a huge amount of cost and a huge amount of time as well. So again, there's been a significant amount of work done in the area of VUR. Just a second, please. There's been a significant amount of done in the amount of VUR where without the help of a radiologist, we have been able to quantify whether this is low-grade VUR or high-grade VUR and use that to, start antibiotic prophylaxis or not. So now let's come to something very interesting. Intraoperative intelligence. Now, this was what Dr. Ankur and Dr. Deva sir were talking a few moments ago. And we have created algorithms which are able to identify structures intraop. So intraoperative intelligence has picked up in a massive way. It's still in the nascent stages, but essentially we are using it to identify intraoperative structures, recognizing safe zones, no-go zones, whether you should be operating in this area or not, and also performing measurements and calculations. So this is a simple project which we have done in our department at SMS Jaipur. we have trained the algorithms to identify the pediatric ureteric orifice. So this is a map of this is an image of the pediatric ureteric orifice, and the tile in the middle is the annotation which has been done by the pediatric surgeon. The surgeon has marked out that this is the ureteric orifice, and the tile on the right is the map of the segmentation map of the algorithm. So if you can see that the orifice has been identified with almost decent accuracy by the algorithm itself. It's almost at the same area, if you can kind of see. So at the end of this particular talk, I'm going to tell you and show you how we created this algorithm and this thing. So the other challenge. So this is an example of a bowel walk which is being done. This was done in bariatric surgery, but you can do this in choledochal cyst or anything. This is a publicly available video. A surgeon is performing bariatric surgery and he's telling, okay, this metal part appears to be 5 centimeters. So the bowel walk which I did, I think each time I handled the bowel, it was 5 centimeters. But when they actually went into depth, they realized that the error percentage was almost 33%. Surgeons underestimated or overestimated the bowel length by 33%. So if you're talking about bariatric surgery, the amount of weight loss becomes excess if you bypass too much of bowel, and the surgery becomes pointless if you bypass too less bowel. I don't need to impress on the importance of the length of the rule loop when it comes to choledochal cyst or biliary atresia, because the entire symptomatology, bile reflex, how much malnutrition, everything depends on the length of the rule loop and the biliary limb and the alimentary limb. So what we did is that we created footage of the bowel graspers and multiple images at different angles of the bowel graspers. And then we trained the data. We fed it into our core AI algorithm, which is a combination of convolutional neural network and transformers, I think, which the previous speakers have spoken about. So I'm not going to delve too much into the technical details. But the end effect was this. We are able to measure the bowel length with reasonable accuracy. And mind you, this is being done in a 2D feed. This is not a 3D feed. So this involved a significant amount of heat mapping, which is essentially figuring out how 2D images would fit in a 3D space. So this was involving a combination of various different AI techniques and algorithms. And at the end, the alimentary jejunum is counted for around 100 centimeters. So I think this has the potential to revolutionize surgery in a massive way. So like we spoke about, like Dr. Devas just spoke about right now, we were able to, segment the gallbladder as well. This was one of the cases which I performed post MS. And as you can see, the gallbladder is being segmented with reasonable amount of accuracy. Also, the distance between the limbs, the distance between the instrument is accurate to the tune of millimeters. So how can AI be used in training? So this is a little bit of endo-trainer footage, where as you can see, I'm struggling with my left hand. I'm able to perform better with my right hand. So my team is also working on how do we quantify ergonomics? How do we give out scores? How do we tell the surgeon whether his right hand is performing better or his left hand is performing better, where he needs to improve? Path of least motion. If you're performing a task, are you performing it efficiently? So at this point of time, we are in a situation in the world where we will actually be able to give out scores for surgeons. Next month, I think in April, we have a suturing competition, a laparoscopic endosuturing competition for residents at AIMS. Maybe 2 years down the line, I think we will be able to evaluate this objectively with AI and actually give out a score out of 100. What is the score you have done in performing these tasks? And I think that has a huge potential to revolutionize the way surgery is being performed. The measurement tool is something which we have built on, and we are trying to see how we can integrate it into the ORs. I believe that we have a huge potential in Kasai, choledochal, undescended testis, where you want to measure the distance between the deep ring and the testis, bladder size measurement intraoperatively, and bowel tumor margins. Now, let me come to a very practical problem. How much blood loss happens during surgery? Now, Siddharth Satish was a founder of a tool called Triton. It was by Gauss Surgical. It was later acquired by Stryker. And what they created was a simple tool using principles of physics, spectrophotometry, and computer vision. What they were able to do is they were able to identify the amount of blood loss, despite the fact that there would have been urine contamination, there would have been contamination by, it would have mixed with RL or any other fluid which have been able to perform, added during the surgery. And they were able to clearly tell you what is the amount of blood loss using a simple standardized lab pad, which was shown in front of an iPad 2. And this was done way back in 2015-16. And right now, it is being used in around 200 ORs in the US. And I believe these kind of technologies have a huge potential in a country like India, because thousands of women in India die during labor, during cesarean sections due to blood loss, and that has a huge that's the area where we can concentrate. And I feel that, in pediatric surgery, neonatal surgeries, where, the amount of blood loss quantification becomes very difficult, because if you transfuse too much, you can push the child into failure. And if you transfuse too less, obviously the child is going to die. So all these problems, there is an AI solution. It's just that there is going to be a little bit of lag period before this comes into commercial practice or, actual usage. So 3D reconstruction in liver resection surgery, I think this is an area where, our robotic surgery teams are going to be super interested. Can you superimpose the CT images into real-time intraoperative? And I think intuitive robotic companies are working on this actively. I think the potential is huge. This is a clear image where the hepatic vein anatomy is being superimposed real time into laparoscopic or robotic surgical feed. And that actually helps the surgeon to decide whether to perform a anatomical resection or a non-anatomical resection. So the possibilities are endless. And as I told you, AI is not artificial intelligence, but it is augmenting intelligence. So let's go and try to find out how we can actually solve problems in real life. Just a minute, please. So this is a tool called CVAT. I hope I'm not exceeding my time. So this is a tool called CVAT. This is a computer vision annotation tool. This is a free tool which you loaded in one of my servers. And as a pediatric surgeon, you don't actually need to sit down and build algorithms to solve these things. Those are all commercially available. These are all available all over in everywhere. So right now I'm going to show you as a pediatric surgeon what you can do. As a pediatric surgeon, your role is going to be in actually helping define data. So the algorithm, if you want to train the algorithm, if you want to create supervised annotation, like the previous speakers told, the real challenge in medicine and surgery is that finding skilled people to annotate is the big challenge, and the amount of annotation you need to do is significant. So to train our ureteric orifice models, we had to use hours of footage. And in each of those hours of footage, if you kind of think about it, each 1 second of footage has around 24 to 30 frames, depending on the type of video. And we actually had to annotate it in every feed. So I'm just going to go. So I'm going to choose one of the box tools. I have created a label. I'll just go back to the this thing. So I've created a label called ureteric orifice, and I'm going to open the task. I have loaded these images. And I preloaded it because it takes a little bit of time to load. And I'm using the track function. If I use the track function, this annotation goes into the next frame as well. So I'm drawing a box around the ureteric orifice. So now this box has come up over here. I can adjust the box a little so that the orifice fits in the center. And then I move to the next frame and the box is a little moved. So I want to extend the size of the orifice. I can do that. I can do that. If I want to move this box somewhere else, I can do that. So if I want to adjust this thing, I can do that. So, and then I go back and save it. And this data can actually be exported to the algorithm in a form in which the algorithm can read. So again, I'm not getting into the type of, getting into the technical details too much, but depending on what type of algorithm you use, you can export this data set. So this was how we built our ureteric orifice project. So now let me go. I think you would have seen the gallbladder image. And now that was a bigger and a tougher problem to solve. Here we actually had to manually annotate using multiple number of points, the cystic duct, the cystic artery, fibrofatty tissue, and the gallbladder. So ultimately what we are trying to create, we have been able to identify the gallbladder, cystic duct, and cystic artery. But right now what we are trying to build is a tool which kind of tells whether the critical view of safety has been achieved. And using that, give the surgeon recommendations whether uh, whether what kind of maneuver should he be performing? Should he delineate the cystic duct more? Should he delineate the cystic artery more? Or should he clear the fibrofatty tissue a little more before clipping? So if you can see, this has been done with a lot of effort. This takes hours. The ureteric orifice thing might have seemed a little simple, but if you're getting into complex anatomy. So let me tell you where the potential is right now. At this point of time, I believe if surgeons collaborate, if you're able to create a great data set, we will be able to identify the vagus nerve while we are performing a tracheostomy fistula surgery. We will be able to identify the hypogastric plexus of nerves when we are performing rectal surgery. This has huge potentials in duodenals. This has huge potential in rectal cancer, where patients are worried about impotence following pelvic surgery. We will be able to identify the ureter in pelvic surgeries. I think that's a big challenge when you're performing uterine surgeries, you're performing tumors in the pelvis, the ureter often gets injured. If you have a technology, either in laparoscopy or even in open surgery, to help you identify the ureter without actually stenting it, I think that would be a huge revolution. And these are all areas where we have the potential to solve problems. When it comes to pediatric radiology, enough data sets and collaboration has not yet started. We are working on a project on anorectal malformations in my hospital, where we are trying to see if we can identify the fistula using AI. But this is just the start of things. I think there's a huge potential both in pediatric radiology, pediatric surgical radiology, and in uh, just a second. Huge potentials. Yeah. Both in pediatric surgical radiology and in pediatric surgery per se. I think, like I said, the possibilities are endless. Thank you so much.
Gurmeet, over to you. Okay, fine. Vinayak, you did a really wonderful job with your presentation, and every time I go through your presentation, probably this is I'm hearing you for the fourth or fifth time. You have become more and more mature and more experienced. It is very evident, and your work speaks for yourself. So we are really proud of you, and we really look forward to working with you. And you gain more and more heights in the field of AI and give a higher representation to India across the world. Thank you for
Thank you
your
so much.
Dr. Gurmeet, are you around? Okay. So thing is like now you have a bigger onus on you. Like you have become a master of AI, especially generative AI and this computational AI. Can you start a few sessions, like certain live sessions, and train maybe like those who are interested? I won't say young people because few people, not so young like you, like me, are also very keen in learning these small tricks of the trade. So can you take the responsibility of teaching us how to do this computational, I mean, what you talk about, doing various research projects on predicting the outcomes and predicting the diagnosis? What is your take about it?
Yes, sir. I think it's definitely possible. I think one of the key challenges which we face in India is, sir, we need to collect data in a more rigorous manner. So when we started off, when I was in general surgery, when I started off on certain projects. So I'll give you a simple example, sir. So I wanted to identify which patients go in for complications post ventral hernia surgery. So when we went to corporate hospitals, I thought corporate hospitals will have better data structures, analyzed structures, patient data compared to a government hospital. But then I realized that every patient, all 100 male patients, and none of them is a smoker. Well, that is statistically impossible. And when we realized, when we went into depth, they said that if I put smoking as a risk factor, insurance is not going to give us money. So the entire data gets confounded because smoking is a major risk factor for postoperative complications when it comes to ventral hernia surgery. But our data structures have to be refined, have to be very clear. So that is like I think what the previous speakers have told, garbage in is equal to garbage out. So if you want to start off with creating predictive models, say for example, outcomes following biliary atresia surgery, outcomes following hypospadias, we need to create in IAPS. I think IAPS has the vision and the ability to do this. We need to create standardized protocols for collecting preoperative and postoperative information, and that information should not be fudged. So we have to create mechanisms in which the identity of the surgeon is not revealed, because they should not feel hesitant that my outcomes are lesser or your outcomes are higher. So that kind of ego issue should not come up when you're collecting data. So this is the biggest challenge. But if we are able to somehow collect a decent amount of information, I think we will be able to create models which actually help the Indian population. Right now, everything is based on Western data. And if you're able to do that, but the best thing right now is, sir, that we are in a position where we are in a position where, even with a less amount of data, we are able to solve problems. And I think that has the potential to change how we are viewing surgery on a massive scale, sir. So I think say with synthetic data, say even so few years ago we needed, say, around 10,000 patients. Right now we don't need 10,000 patients. We are able to work with, say, 1,000 patients, sir.
So that is really very heartening to know. And I know it is a hard tasking business, but we do have dedicated people, and let us discuss it more in detail after this meeting is over. Dr. Gurmeet has probably now joined. Dr. Gurmeet, do you have any questions and you want to?
Thank you, sir. It was a great session by Dr. Vinayak, and I think it will be a great enlightening session also for the young residents and the young surgeons, and in fact, the other senior members. Because the importance of AI is that we have to first of all recollect the data, and then we have to create the algorithm. So all the senior persons who are available with us, we can have the data from them. We as an IAPS can make an algorithm for that and can get the things done in a very better way and can create an AI tool on our IAPS website also. And another, I would like to ask a few questions that have been asked. Mr. Vibhor Sachdeva has asked a question: how can we as a surgical residents take part in AI-based research? Over to you, Vikesh, sir. Please, can we have the answer
Vinayak,
for that?
I think Vinayak, you are the right person, and you are the right person on the stage to answer this question.
So yes, I think like Vikesh sir said, we can start off with small workshops about how you can come up with with these kind of just things. So I think one of the first thing is that choose a burning problem. Choose a problem. A problem. Choosing the problem is the first step. Choose a problem which kind of hurts you a lot, because only then you are in a good position to solve it. If you feel that it's not a big issue, the amount of motivation you will have to solve it is going to be very less. So that's going to be the first step. Second step is to collect data. So you will have to collect data which you feel is relevant and what could be also irrelevant. Say for example, if you're collecting data on biliary atresia, you feel that this patient is unlikely to go in for so the PTNR value is important, GGT value is important. We all know when it comes to identifying liver failure or progress of jaundice or something of that sort. But we may think that renal function tests are not very important. We may think that CRP is not very important. We may think WBC count or neutrophil count is not important. No, that's not how you should be approaching the problem. You should try to collect as many data points as possible. How AI works is something which we still kind of find it difficult to understand. So the algorithm output might be very clear that if in this particular patient neutrophil count is elevated along with CRP is decreased and GGT is slightly elevated, this could lead to biliary atresia. I'm just giving you an example. I'm not saying that this is the reality. So you will have to collect data, a widespread 360-degree data. You have to collect clinical data. You'll have to document the symptoms. You'll have to document this thing. Second thing is that there is a lot of work you can do in surgical radiology. I'm talking about, say, anorectal malformations. I'm talking about tracheostomal fistula, intestinal atresia, congenital pouch colon. So in the northern part of India, CPC is like a big problem. And if you go to southern part of India, a radiologist and pediatric surgeons have not seen too many cases of CPC. It's a rare problem. So this is like a classical good problem statement to attack. Say, for example, you have about 500 cases of CPC X-rays and another around 2000 cases of HD or normal babygrams. We can create a fantastic tool which is able to identify CPC and possibly even tell you what is the type of CPC over there. So I think that's like a good problem to solve. All it needs is a surgeon, an expert to validate this thing. You can start off, as a resident, you can start off by saying this is CPC, there's CPC. A senior professor like Dr. Vikesh or Dr. Gurmeet can sit down and validate it. Okay, this is CPC, this is not CPC. And what you should really do is actually correlate it. That CPC should not be a colonic atresia. Should go back to the clinical findings and correlate it. This was actually CPC, yes or no. So once you're able to create that database, we will be able to, feed that into the algorithms. To be honest, feeding it to the algorithms has become the easiest part of the entire process because much of it is available on the internet, free of cost. You need minimal coding or in fact no code AI. To be honest, people tell me I take classes in AI, but I've never taken a coding class. I don't think I code well at all. Even if you ask me to code to save my own life, I don't think I'll be able to code. It's just that I understand what is the approach I have to adopt to solve this particular problem. So I think I have a reasonable understanding of that thing. What tool to utilize the data? As surgeons, I think we have to understand that when it comes to learning AI, we should not try to focus too much on code, learning Python, GitHub repositories, all that sort of stuff is, you are never going to reach a position where you're going to train as well as a person who has spent 5 years doing a PhD in artificial intelligence. But what is our strength? We have to build on our strength. Our strength is the clinical aspect. So, like that computer vision annotation tool, which I showed you, my role in building that algorithm was actually using my own clinical knowledge, whatever cases I have seen, identifying the ureteric orifice. I was not sitting down and actually choosing what algorithm to even feed it into. So I have a team. They tell me, buddy, you export that data into this format, and then we create these algorithms. Obviously, I have a reasonable understanding of how that works. But the clinical role you play is very important when it comes to building this algorithm. So it's ultimately a lot of collaborative work. You will have to build on your clinical knowledge. And as a resident, I would say, learn your surgical radiology well, learn how to interpret X-rays well, learn laparoscopy and this thing well. That is going to be the future. And your domain expertise is much valued in the AI space than anything else.
Doctor,
Yes,
thank you very much.
very well said, Dr. Vinayak. I think this would answer Dr. Vibhos Sachdeva's question. When we can have more and more pieces for the residents in the coming part, that will be based on the AI, and we can have a collaboration of that with the IAPS also.
Definitely,
I think
sir.
there is.
I think that should be possible. I think with Dr. Vikesh and Dr. Ramesh sir here, I think that's going to be definitely the future for sure.
Ramesh,
Another question, sir.
yeah.
Can I add a couple of points?
Sure, sir.
Now, Vikesh has projected a beautiful slide which shows the roadmap of AI. What are the various things? Now, there are a lot of things which are individual efforts. Like, for example, AI awareness an individual can do, understanding AI an individual can do. And there are a lot more things which, as an institution or as an association, we should pitch in together. For example, application at an organizational level, then collecting data, that is a huge effort an individual cannot do. So we actually need a team. So I think Vinayak probably can form a team in consultation with IAPS to take it up further. I mean, we have a lot to achieve, and then we need to create what all we can achieve in the next few years. I obviously you alone cannot do it, so you need some team of members who are both juniors and the seniors who can actually develop a lot of things for IAPS. It can be useful for the association management. It can be useful for the research. It can even be transformative. I mean, we have heard from the previous two speakers that, for example, identifying the pneumonia can actually have a translational benefit on impacting the mortality, morbidity. Then identifying the COVID-related heart problems, which was actually a byproduct of that lung pneumonia identification, but it helped a lot of them predicting this. So they can actually have an impact on the life of the children. But we need to have a team. It is not one man job, and obviously Vinayak is involved in so many other things, as I know, and it involves a lot of efforts. And I think we should actually brainstorm on how we are going to achieve all this roadmap, whatever we are planning.
Yeah. Thank you, Dr. Ramesh. Now, we are very fortunate to have our current president, Dr. Sumit Biswas, sir, with us. Sir, would you like to say a few words of wisdom and encourage us, like in this particular endeavor? Dr. Biswas, sir. I need to mute you or what? Yeah, I'll ask you to unmute. I've asked you to unmute, sir. Please accept the invitation. Yeah. Yeah, now you're audible, sir.
Very good arrangement, Vikesh. Very encouraging. I've already in chat wrote you that we can think of AI Collegium, which may be contributory, and which there should be some honorarium for the tutors. Otherwise, it is very difficult to sustain. So that's my short message, that we should think of future, and it should run. And I'm in a function. Okay. So now I'm in a marriage ceremony. So I am stopping here. Okay.
Thank you. Thank you for your valuable one-word advice, for which you are very famous and you win my heart always, sir. Thank you very much, sir. And if I think this is going to be a continuous process, and these AI sessions, again, the second part is on 16th of March, and we will keep on like delving into more and more details based on the feedback of the audience and the participants. Thank you everyone for joining on such a busy day where three conferences are going on, and our program had more than 100 attendance most of the duration of the session. Thank you all the speakers. Thank you all
Thank
the.
you so much. Thank you so much, sir.
We call it a day. Thank you.